Hey folks, this is lesson 2, laws of logarithms. So remember that logarithms are simply another way to express exponents. So log 3, 9 is equal to 2 because 3 squared equals 9. In working with powers of the same base, you often use the laws of exponents. These bad boys. I was just teaching these to my grade 9s. So the power of powers, quotient of powers, power of a power, and root of a power. These should all be familiar. Since logarithms are exponents, similar laws exist for logarithms. The logarithm of a product and the logarithm of a quotient. So these are the first two rules that we're going to go through. To multiply two powers of the same base, you add the exponents. Therefore, it should follow that the logarithm of a product equals the sum of the logarithms of the factors. What the heck are we even talking about here, folks? Well, that means if we have some logarithm where we're multiplying two numbers, so 16 multiplied by 64, and you'll notice that it's log base 2. Well, does that equal log 2 of 16 plus log 2 of 64? Do you see the difference there? The first one we're multiplying the two factors, and the other one we're going to be adding the two logarithms. Well, let's evaluate our left side here. Okay, first of all, what is 16 times 64? Well, by the magic of mathematics, it's 1024. So 2 to what exponent equals 1024? And it turns out that it's 10. Okay. Now we go ahead and check out the right side. So log 2 of 16, that's basically saying what exponent of x will equal 16. And the exponent there is 4. And the second part here, log 264, means that 2 to what exponent equals 64, and we know that that's 6. So 4 plus 6 is in fact 10, and 10 equals 10, so we're good to go. Okay. So the logarithm of a product tells us that if we have two factors multiplied, we can separate that into two separate logs. So another example, does log 3, this is the quotient rule. So we're dividing two factors here, okay, division. So we want to see, does dividing two factors, 27 and 9, give us the same as subtracting each of those separately? Well, 27 divided by 9 is 3. So log 3 of 3, we're basically asking what exponent of base 3 gives us 3, and that's 1. So log base 3 of 3 gives us 1. Now the right-hand side of our equation, what exponent with base 3 gives us 27, and that's 3. And what exponent of base 3 gives us 9, and that's 2. And 3 minus 2 is 1. So in fact, it follows that the logarithm of a quotient, if you have a quotient, meaning you're dividing two factors, you take the numerator and subtract the logarithm of the denominator. So let's try some here. Evaluate each expression by applying the laws of logarithms. Well, this is addition, so it's telling me that we need to multiply those things. So let's create one logarithm. The base 5 stays the same, and it's going to be 100 multiplied by 1/4. Well, if we simplify that, we're going to get 25. So what exponent with base 5 gives us 25? And that exponent is 2. So it simplifies to just 2. All right, I'm subtracting logs with the same base, so this is the quotient rule. So I can create a single logarithm, base 2, and 384 divided by 12. Well, 384 divided by 12 simplifies to 32. So I get log base 2 of 32. So what exponent with base 2 gives us 32? And that exponent is 5. So our answer here is 5. Okay. I'm adding these two, so this is the product. So what I can do is create one log with base 6 and I'm going to multiply those two numbers, and I get log base 6 of 36. Now what exponent with base 6 gives us 36? Well, that exponent is 2. So our answer here is 2. Subtracting, so this is the quotient, so create one logarithm and divide your two factors. So log base 5 of 5, so our answer is 1. All right, I'm subtracting logs. So if there's no base, nothing going on here. Well, this is something you have to remember. The default is 10, okay? 10. So let's use that information. This is the quotient, so we're going to create one logarithm with base 10. Now, you don't have to write base 10. And we are going to divide those two. Now, this will simplify to 1/10. So if we think about this, 10 to what exponent will give us 1 over 10? Interesting problem here. Well, 1/10, if you recall, we can bring up to the numerator and give it a negative exponent. So it's -1. So our answer here is in fact -1. Same base, so we can divide 50 divided by 0.4, and that is going to be 125. So what exponent with a base of 5 gives us 125? And you are correct in thinking it's 3. Good job, you. Pat on the back. Logarithm of a power and logarithm of a root. So two more laws that we can introduce are these. Now, I'm pretty sure these are on the diploma formula sheet, so you don't have to remember them. Well, let me just double check that. But you will need to know how to use them. Yeah, so you're given these ones, but you need to know how to use them. So what does this one tell us? Well, it's basically the same, but you'll notice that the this part of the logarithm here has its own exponent. Okay, this is not on the other side of the equation. This is directly affecting the logarithm. So what you can do is you can actually take this n and you can bring it to the front of the logarithm, right there. Okay. So same thing, if you have a fractional exponent, you can do the same thing. Just bring it to the front of the logarithm. And it means this implies multiplication for both cases. Okay? It implies multiplication. So let's do something here. We have this little exponent here. So what we're going to do is we're going to bring that down to the front, and you're going to get 5 log 7 of 49. Well, this log 7 of 49 we can evaluate to just 2. So 5 multiplied by 2 is 10. Okay, first thing here, we got to convert this radical to exponential form. So this becomes log base 3 of 27 to the 1/5. Now that 1/5 you can bring to the front. Log 3, 27, it can simplify to just 3. So 1/5 times 3 will give us 3/5. And that's our answer. All right, let's do a couple more examples here. So this becomes 2 log 10 of 100. So it becomes 2 times 2, which is 4. The first part here, we've got the product and the quotient. So you can create one log, 8, and what we're going to do is 24 multiplied by 4 divided by 3. So you get log 8 of 32, and this one's a little tricky. So 8x is equal to 32. If we use common bases, you're going to get 3x is equal to 2 to the 5. So 3x is equal to 5, and x is equal to 5/3. Tricky one. Okay, 2 product rules. So we're going to multiply those 3 numbers. So create one logarithm, base 4, and we're going to go 48 multiplied by 2/3 multiplied by 8. And that will simplify to, I just got to check my notes, 256. Okay, and if you think about this, 4 to the x is equal to 256. So x, this whole thing must equal 4. That's our solution. Because 4x equals 4. All right, here we got quotient and then product. So we're going to create one logarithm, base 4. And the first thing we're going to do is do 20 divided by 5 and then multiply by 8. So we're going to end up with log base 4 of 32. And again, using common bases, 4 to the x is equal to 32. So 2 to the 2x is equal to 2/5. So 2x is equal to 5, and x equals 5/2. All right, we're getting there, folks. Product and quotient. So 1 log 9, and then we're going to go 36 multiplied by 18 divided by 24, and you end up with 27. So common bases tell us that 9 to the x is equal to 27. So 3 to the 2x is equal to 3 to the 3. 2x equals 3, so x must equal 3/2. Changing these to radical form, we're going to get log base 2 of 5 to the half minus log base 2 of 40 to the half. The quotient rule says we can divide those. So we get log base 2 of 5/40 to the 1/2, bringing the 1/2 down to the front. Now we got to do a little, 5/40 can simplify to 1/8. Okay. So we get 1/2 multiplied by -3, which gives us -3/2. All right, just writing these as a single logarithm. They're all the same base, so log 5, and then it's going to be 24 multiplied by 0.5 multiplied by 3. So this equals log base 5 of 36. Okie dokie, and we get log 3 multiplied by 50 divided by 2, and that will simplify to 75. All right, we have a coefficient out front, which means it can become the exponent. So we're going to get log 7 of 2 squared divided by 3 multiplied by 75, and that will simplify to 100. All right, 5.8 multiplied by 7.9 divided by 2.5, and that will actually simplify to 18.328. There you go, folks. Interesting. All right, you can even use variables to sort this out. So quotient rule says we're going to multiply those two, so mn, but then we're going to divide by p cubed. We get half log AB over C, and then if we apply the exponent, you can get log AB over C to the 1/2, or you could even write this as log root AB over C. Two more. Okay, we're going to divide these. Multiply these. So A plus B and A minus B. What does that look like? Looks like we can FOIL this. So you're going to get A squared minus B squared. Neato. All right, and what do we got going on here? So we've got log A. Now let's just change the form here. So log A minus log B cubed plus log root 5 with an exponent 5. Well, those exponents are going to cancel each other out. So we end up with log A minus log B cubed plus just log C. So we get log AC divided by B cubed.